So, expected value. We have this rule in our formula sheet, and let's start to make sense of it. First of all, how do we think about the expected value? Let's just say that I've got a really big class of students, 500 students. In grade 8, we would talk about the average height, and we would calculate the average height of the students by adding all their heights together and dividing by how many there are. Let's just say the average height of my students is 170. So that would be X bar, wouldn't it? X bar would be 170. So I randomly select one person out of my class, out of those 500 kids. I'm just going to say, hey, you, pop up here. What would you expect their height to be? How tall do you think they would be? What's the most likely outcome of their height? Would you be happy to say that that's 170? It's most likely that they're going to be an average height, the average being X bar. In about grade 11, we start talking about average being mu being the centre or average of a distribution. So really we've got X bar is the same as mu. Well, it's also the same as what do we expect. So we're going to say that's the expected value, and then all of a sudden we get this sigma PIXI. That's a subscript I. Anyway, we're going to get there. That's how we're thinking about it. Expected is what do you expect to get? What's the average results? That sort of thing. How about if I roll a die 600 times? How many times do you think I should roll a 4? How many 4s do I expect to get? Well, if I roll a die 600 times, I'm probably thinking I'm going to get 100 4s. So that's another way of thinking about the expected value, is if you're going to do something, what do you expect to get? Okay. I'm going to toss a coin twice, and this is a straight up probability distribution. In your test, this will be a no calculator scenario, and you need to fill in the probability of getting 0. Let's call, see that capital X? We're going to call capital X is getting a heads. So this P of big X equals little x. In here, it's the probability I get 0, because that's the X, heads. That big X is heads. So this stands for 0 heads. I could get 1 heads, or I could get 2 heads. So how do I work out, if I'm tossing a coin twice, how many heads I'm going to get? Well, that's going to be a two-way table. Yes, it's got to be quick. So 0 heads would be, 1 heads would be, and 2 heads would be 1/4. Okay, let's just multiply down. I've got a 1 in 4 chance of getting 0 heads. So if that actually happens, I end up getting 0 heads. So multiply down. 0 times 1/4 is 0. I've got a 2 in 4 chance of getting 1 head. So if that actually happens, I'm going to get 1 lot of that, or that times 1, which is 2/4. And I've got a 1 in 4 chance of rolling 2 heads. So if that actually comes out, I'm going to get 2 out of 4 heads. So let's just add them all together. 0 plus 2/4 plus 2/4 is actually 4/4, which is 1. Hey, if I roll a coin twice, how many heads do you think I should get? I'm probably thinking I should get 1 head. So that's our expected value. So if we think about that expected value rule, was mu, which was the sum. Well, in grade 11, it's sort of x, p, x equals x. Because this is the sum of each of them multiplied together. So x times p of x is x times p of x. And because I'm adding them together, I'm adding them all together. In grade 12, this merges to become p subscript I, x, I. The I stands for an iteration. So if you think about iteration being, our first iteration is small x is 0, p is 1/4. The next iteration, x is 1, p is 2/4. The next iteration is x is 2, p is 1/4. And we're multiplying them together and then adding them across. Okay, how much fun did that look like? Oh, and here, clearly, it equals 1. In this particular case where I'm rolling a coin, tossing a coin twice, how many heads do I expect to get is 1. Okay, I roll a die 6 times. Let's set the big X equal to rolling a 1. So here, this 0 represents, out of 6 rolls, I get 0 ones. That's 1 1, or that's 2 ones, or that's 3 ones. So here we're going, oh my gosh, it's either a 1 or it's not a 1, binomial. So probability equals NCR, P to the R, Q to the N minus R. So this 0 would be 6C0. Success is 1 out of 6, and I want 0 successes. Q is 5 out of 6, and I want 6 failures. I'm going to put that in the calculator and put the number there. For the number 1, my probability will be equal to 6C1. I want 1 success, 5 failures, calculator, number goes there. Blue, P equals 6C2, 2 successes, and 4 failures. Then that number goes in there. Clearly, I have done that already. So, just using a calculator, I have come up with those numbers. Remember, X was rolling a 1, and I want the expected value for X, which is how many 1s do I expect to roll? Well, common sense tells me it's going to be 1, but my rule is the sum of PI XI. So I need to get this X and the P and multiply them together to get an answer, which is X times P X of X. So I'm going to multiply down, and then I'm going to add across, take a screenshot of that, get your calculator out, add them up, And you're going to get, let's put it in red, 1. So isn't that crazy how those numbers look so crazy and small and difficult, and yet when you add them together, you actually come out with what it should be. If I roll the die 6 times, you'd think I would get 1, 1. Okay, that's the expected value. Go to it.